Two cars collide at an intersection and stick together. The first car has a mass of 1,500 kg approaching at 20 meters per second due south, and the second one has mass 800 kg and approaching at 30 meters per second due west. Find the magnitude and direction of the final velocity of the two cars. So here is the scenario where the two cars, one is coming, is going in the southern direction, and the other one is going in the western direction. Then these two cars collide at an intersection, and then they stick together and begin to move with a common speed. Now, the question that we are required to find is the magnitude and direction of the final velocity of the cars. So this is the question that I'm going to consider. So let us begin by drafting something. So we begin by drafting the compass. We have the east, west, north, and south. So now, in order for us to find, let's say solutions. In order for us to find the solutions in the easiest way, let us come up with a diagram that is going to help us to find the solutions without facing a lot of challenges, or with the easy. So we have the first car that is going in this direction, the western direction, due in the southern direction, due south. So we have this car which is going in this direction. Then we also have the second one which is going in the western direction. In the western direction, then we are told to find the magnitude and direction of the final. So let us say this will be the final after meeting. So we have this one. Okay, so this is forming a 90 degrees here. We have the first one, which has 1,500 kg approaching at 20 meters per second. Then we also have 800 kg approaching at 30 meters per second. Now, in order for us to find this, to find the final velocity when they stick, when they collide, they're going to stick, and when they stick together, they're going to be moving with the common or with the same speed. So from here, what I want to do is we're going to resolve this one and this one in their respective components. In their respective components. So let me just erase the first part here. We know that since this is the question that is involving collision, we have an aspect of momentum. So momentum is given by mv. Now we can resolve. Let us resolve these in their respective components. We resolve the momentum of the two cars, or the momentum of the two cars in x and y. Components. Before we resolve, let us come up with a common mass. Okay, the total mass. Total mass is equal to 1,500 plus 800, which will give us 2,300 kg. Okay, now in x, we have m1 v1. This is in x plus m2 v2. This must give us m1 plus m2, since it is the common velocity we are looking at. So it's going to have the common velocity. They're going to stick. We should have said m1 vx plus m2 vx, but this is simply, it is one and the same thing. So here what I'm going to do is in x, here for this one, which is the m1, for this m1, and this one as m2. So this one we have 0 in x, we have 0 plus. So for M2, we have 800 times 30, which is equal to 2300 Vx. So for this, we are going to get, here we're going to get 24,000 is equal to 22,300 Vx. We can divide also here, 2,300. So this and this will cancel, and what we're going to have for Vx, 10.435, which is simply 10.4 meters per second. So let us proceed with the y. The y component we have got in y, okay? M1 V1 plus M2 V2. This will give us M1, M2, then Vy. So here in y, for M1 we have 1,500 times. So this is 20 plus. Here in y it is 0, which will give us 2,300 as the total mass Vy. So we can divide by 2, 3, and also here by 2,300. So what we're going to have is Vy is equal to, this one will be 30,000 over 2,300. And this one is going to give us 13.0435, which is simply 13.04 meters per second. Now, this is Vy, and we have Vx. So from this, we can come up with now the magnitude of the two velocities. So we're going to say v squared is equal to vx squared plus vy squared. So we can now plug in the values. 10.435 squared plus, so we have v squared also here. So from this point we can even introduce the square root, there's no problem. And what we're going to have is the square root of this 10.435 squared plus this, we are going to get 16.7 meters per second. So this is the magnitude of the final velocity. Now for the direction, so for the direction we have this. So let us say this is the compass. Okay, here we have 10.3, okay, 10.435, just this. Then here in the one we have 13.04. So let us find this angle here. So from this point, we are able to see that when we use n of the trig ratios, we are going to say, okay, let's use tan. Tan theta is equal to, so this is our Vy and this is our Vx. Vy over Vx. Theta will be equal to the tan inverse of Vy over Vx. So we plug in the values. We're going to have here tan inverse of 13.04 over 10. Let's say 4. Okay. So this one, what we're going to get is 51.34 degrees. So this is from the positive x-axis. Now we can also find this one, since this we have used with respect to the horizontal x or the horizontal axis, which is this one. In fact, from the positive x-axis, we can also find from this. So from this one. So this one, it is going to be a 90 minus 51.34. And this one is going to give us 38.7 degrees. This one, it will be north or east of north, or this one from the positive x-axis. So you can either use this one or this one. Why we are subtracting this from 90 to get this is because this one or this is a right angle. It is a right angle. So this plus this must give us a 90 degrees. So this is how you should go about this. And in an event that you are required to find also the loss in terms of kinetic energy, just subtract the total kinetic energy final from the total kinetic energy initial. So initial kinetic energy minus final kinetic energy, that is the loss in kinetic energy.